Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is a very hard puzzle, and it looks very hard, but it looks fascinating too, which is why I wanted to try this. So let's give it a go. Today's puzzle is called Life Finds a Way by Michael Lefkowitz, and here are the rules. We have chaos deconstruction, where we need to locate 9 cell orthogonally connected regions in the grid. And it's not 9 3x3 boxes as normal chaos deconstruction is. So this is going to be kind of hairy. The grid is 9x11, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, this is 11 and this is 5. I counted before I started because I didn't want to try this if it was like 11 by 11 because that seemed like it would be hairy. 9 by 11 still isn't great, right? That means, okay, so a total, well, okay, well, we'll get into that when we start solving. Anyways, what does a 9-cell orthogonally connected region mean? It means you have to be able to go from any cell in the region to any other cell in the region, all while staying within, all by going through edges, and all while staying within the region. So this is an example of a valid 9-cell orthogonally connected region. This would not be, because to get from this cell to any other of the cells in the region, you would either have to go through a corner or go through an edge, but go outside the region to connect. So that's not allowed. And you could not have something like this either. Even though they can connect to each other through an edge, they can't connect to the rest of the cells in the region through an edge just while staying within the region. They would have to connect through a border or a corner, or would have to go outside the region. So those are examples of orthogonally connected regions. We need to fill the region with the digits 1 through 9 so that there are no repeats in any row, column, or region. Cells outside regions should be left empty. So again, we cannot have repeats within a row, a column. So this is normal. This is how I usually describe normal Sudoku, because you can expand it to essentially stuff like this, right? But it's not filled every cell in the grid. It's filled every region with the digits 1 through 9 so that there are no repeats in any row, column, or region. Nice. I like how we used that. And cells outside regions, again, should be left empty. Okay, so yeah, let's do the thing in. Let's kind of give you a hint. It's not really that much of a hint if you think about it, but basically it's a deduction that anybody can make. Normal, so you have to fill 9 by 9 cells of the regions. All the rest are blank. That means you have 81 digits that must fill this region. So then the rest of the region has to be, we have 9 times 11, that's 99 cells. That means 99 minus 81 is 18 blank cells outside the region. So we have to have 18 cells that are not in a region. And that's just normal deduction. Anyways, let's continue. We have killer/index lines, where digits on lines do not repeat and must sum to the attached clue if given. So that means all cells, all lines are killer/index lines. So you cannot have repeats, and they must sum to the attached clue if given. Also, for the index lines, if the nth cell along a line, starting from the diamond, contains a digit, it indicates the position along the line where the digit n appears. For example, a 4 on the diamond puts a 1 in the fourth cell along the line. So, for example, if this were a 4, that would say 1, 2, 3, fourth cell must be a 1. So that would be an example of how the index part line of the index line works. Or I guess we could use this one here, right? So say this was 4. 1, 2, 3, fourth cell would have to be a 1. And remember, digits on line must sum to the attached clue if given also. So these act as both killer lines and index lines here. We have gold blooms. Gold blooms are always in a region, and region borders divide lines into segments, and a digit on a gold bloom indicates the number of cells on its segment. Oh, interesting. So all of these blooms are always in a region, so that means they always have a digit in them. And region borders divide lines into segments, and a digit on the gold bloom indicates the number of cells on its segment. Interesting. Huh. Okay. So that would mean say this line Yeah, I'm not sure how to do this without like essentially starting to solve this. How do we give an example of this? Well, okay. Let's say we had this was a region or part of a region, and then this was the other part of the region. This was another region. So this would have to be a 4 to count the number of cells on its segment, because this is all the same region. This would then be 2, because it only has 2 cells in the segment of its on this line. So that would be that. Yeah, those are examples of how gold blooms work. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Oops, not copy go. Let's go. Okay. So, blooms are always in regions. We also know you do not have repeats on a line. So these have to be different regions. So this must be a size segment of 1 or 2. If it's 1, there's no way it's adding up to the rest of the digits. So this must be 2. So this has to be a region by itself. It's gonna be blocked here because if this was the same region, these would be the same digit, which is not allowed. This is a different region, and it must be a different region than this. Because, again, you can't have repeats on the index line. So this is 2. This could be up to... So it's 1. Could be 1, but the problem is it doesn't add up to what 2 does. Oh, wait. Hold up. It doesn't have to add up to the same sum. I'm so used to segments adding up to the same sum that I just assumed that. But it doesn't have to. So this is 1 or 2 still. So this is 1 or 2. Wait. If this is 1, that means this has to be a digit, right? Yeah, because 2 would have to be in the first position. So this can never be 1. Therefore, it is always 2. Never. That always is the case then. So 3 has to be somewhere along this line. It could be here. So this is either 1. It could be 1 cell long. It could be up to 1, 2, 3, 4, 5, 5. 1, 2, 3, 4, 5. So this could be 1, 3, 4, or 5. This is a digit. It's a separate region. I guess it could technically be pink. This could be 1, 2, can't be 2. 1, 3, 4, 5, 6 as possibilities. So 1, 3, 4, 5, 6 are possible ones here. These are different regions. This is quite possibly a pink. These are different regions. This is red, so this could be at most 3. This could be at most 4. I'm gonna mark this as green for now. 1, 2, 3, 4, 5, 6. So 5 is always going to be in... So this adds up to 10. 1, 2, 3, 4, 5, 6, 7, 8. So we have to have, out of the 36, we are missing... So 1 through 8 adds up to 36. One, 2, 3, 4, 5, 6, 7, 8, 9. This cell can be 1, 2, 3, 4, 5, 6 length and size. I guess we'll make this light, and we'll make this medium for now. It could be pink. This can be 1, 2, 3, 4, 5 in size. 1 has to be somewhere along this line. This adds up to 10. So it's either... what can it be? 1 through 4. 1, 2... Can't be 7. 1, 2, 6. Right? No, 1, 3, 6. Okay, this is... Okay, no, never mind. This is guaranteed to have a 2 and a 4 in it. Because it's saying these have to be digits. So in the nth cell along the line... Right. If this is 1, 2, or 3, that means 2 has to be somewhere in 1, 2, or 3. We also have to have a 4 here. The only combination of digits that have 2 and 4 that add up to 10 would have to be, with everything digit being unique, is 1 through 4. That means these can never be digits here. So these are... I usually use medium gray as a region. Okay, we're not going to be using medium gray as a region. We're going to be using medium gray as not possible to be cells. So this cannot be 4 anymore. This has to be 1 or 2. And this is 1, 2, or 3. 4 cannot be in the second spot, so this must be just 1. So this has to be a single region. That means this must be 3 as a region. So 2 has to be in the third position. So this is 2 and this is 4. And these are all the same region. So there's a boundary here, there's a boundary here. These are red or medium. Okay. 1, 2, 3, 4, 1. So this has to be 1 through 6. So we're missing 6 value in the digits. So it could be missing a 6. It could be missing 1, 5. It could be missing 2, 4. Or it could be missing 1, 2, 3. We're guaranteed a 5 here. So that means it can't... okay, so it could be missing 6 still. It could be missing... what else? It could be missing 6 still. It could be missing 2 and 4, or 1, 2, 3. Okay. This green could actually be part of this pink region. We don't know. That means this is 5 at most. So this is 1, 3, 4, or 5 here. These digits, if they're here, have to be 1 through 3, but they don't actually have to be a region. 2 can never be in 3, 4, or 5. So we're also going to mark with these with 0. So these could all be 0 too. This cannot be 0. 2 could be in... I guess I could mark these as 0 then, instead of gray. And that would allow me to keep colors everywhere. All the colors in just the same set. So... 2 can only be in 1, 2, or 3. Cannot be 4, 5, or 6. So this is 0, 1, 2, 3 here. This can't be 2 because of the 2 in the column. This could be, again, 0, 1, or 2. This can't be 2, though. So... yeah, 0, 1, or 2... These are definitely on the loop. This has to be definitely on the loop. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 could be. So 1 through 9. That's a possibility. This can't be 3. So 2, if there is a 2, is one of these two. Can this actually be 5 on the segment? If it's 5 on the segment, it's guaranteed to be... these are all the same cell. I don't think so. This has to be a 9-cell region, orthogonally connected. 1, 2, 3, 4, 5, 6, 7. It would have to be 8, 9 here. So one of these would have to be 2. Or 3. Right? You would have to be 1, 2, and 3 here if it's open. So if it's 5 blocking off this, this would have to be... okay, if it's 5 here, this has to have 5 in the segment. It cannot... it has to be missing just one digit worth 6, so therefore it must be missing 6. So all of these digits must be filled. And they cannot be the same region as this because we already have 2, 3, 4. So therefore, it's a different region. Which means going here, it has to go out this way. But then there is guaranteed a 2 or 3 here. Which would mean that's not the same region. So this cannot be 5. Can it be 4? Maybe. If it's 4, 5 has to be in the 4th spot. So it could be 4, 5, and 6. No, it can't be. You're missing 2 digits at least. But if you're missing 2 digits, it can't be... yeah, so it can't be you're missing 2 digits. it means you have to be missing 1 digit, which has the same problem here. So this cannot be 4. If you're 3, wait. If it's 4 digits, that means 5 are filled, and it has to be these 5. But you could actually go this way, right? And it would be full. So you'd have 4 here. So yeah, you could actually go here, and this would be a 1 here. That could be possible, and this could be 5. But if this were 5, then this would have to be 3. So 4 would not actually work there. I guess it could go that way. No, but then we're guaranteed a 1, 2, or 3 here, if that's the case. Maybe we can go that way, and that would be 5. I guess it could do that way. Yeah, you could go that way. 1, 2, 3, 4, 5, 6, 7, 8, 9, and that could work. Okay. But no, the box borders would divide into regions, so this would be 4 as a region. So that's not possible. So 4 as a region would mean it has to go at least here. It could be like that. That doesn't work. It would have to be like this. And then this would have the same problem. So this cannot be 4. It could be 1 or 3. Okay, this digit cannot be 1, 2, or 3. So this is either 0, 4, 5, or 6 here. Okay, this is definitely the border of a region. So we have 3 here. How does that work? It would have to be these 3, and then this would be a separate region. That means you're not missing 3 digits. You have to be so you have 3. So 5 would have to be in the 3rd segment. So 5 actually has to be one of these 2 cells here. If you have 1 as a segment, it's possible you would be missing either 2 and 4 or 6. Hold up. If you have 3 as a segment, again, yeah, you can't do here. So the 3 as a segment would have to be these 3, right? Because if it cannot be part of the red if it's 3. 4 could not be part of this. 5 could not be part of this because it would have to be like all 5 here. 4 cannot be part of red, but the problem is then it would have to be like 1, 2, 3, 4 as a segment, or 1, 2, 3, 4 as a segment, and that would block the red. This couldn't work as a segment because then this would be a different segment, and then this would not be orthogonally connected to each other. So 3 doesn't work either for the same reasoning. It would have to be either 1, 2, 3 this way, which means that's a separate segment. And then the red would be blocked, right? So it would have to go around here, and that would block the red. Or if it didn't, this would not be an orthogonally connected region. Or, so 3 has to be that way, but the problem is that would force 4, 5, and 6 to be on the line. 3, 4, 5, 6 doesn't add up to 15. So this can't be 3. This has to be a 1 here, which eliminates 1 in the rest of the region. This can't be 1. This can't be 1 anymore because of the 1 in the row. This could be... Oh, no, can't be red. So this has to go like either here or here. So this is blocked this way. That means 5 has to be here. That eliminates 5 from here. This is not a gold bloom, so it doesn't have to match the number of cells in the region. That means this can't be 5 and this can't be 5. Okay. 4 can only be now in, cannot be 2, cannot be 1, cannot be 5. So it could be 0, 3, 4, 6 here and 0, 3, 4, 6. So this adds up to 6, 1 and 5. It's either 3 and 6 with themselves or 3, 4, 5. Huh. So this cannot be green. We'll label this yellow then. It could go down here. It could go up here. This is a segment of 1. This can't be 1 or 2. It cannot be the full 9. 1, 2, 3, 4, 5, 6, 7, 8. Can't be the full 8 either. So this is 3, 4, 5, 3, 4, 5, 6, 7 as possibilities. That means 3 has to be one of these. Can it actually be the full 1, 2, 3, 4, 5, 6, 7, 8, 9? Yes, it could be. Yeah. We know there's a 3 somewhere along this. So on this 28 line, 1 through 7 adds up to 28. So you're missing either an 8, you're missing 2 digits adding up to 8, or 3 digits adding up to 8. That could be 1, 7, 2, 6, and 3, 5, or 1, 2, 5, 1, 3, 4. You cannot be missing 4 digits, though, adding up to 8. Huh. These, again, 1, 2, 3, 4, 5, 6. So this is digits 1, 0, 1 through 6. Again, we are missing only 18 cells from a digit. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it's a full 9. This is a full 9 also. 4, 5, 6, 7, 8, 9. So this could be all 1 through 9. Interesting. Okay, so region borders divide lines into segments. These digits again, 0, 1 through 4. 0, 1 through 3 here. Digit number of cells on its segment. Okay. So if this is 3 and... Okay. So it's either... This adds up to 1, 3, 5, 6, or it's 1, 2, 3, 4, 5. If it's 1, 3, 5, 6, that means this cannot be 3. So this would have to be 3 here. This would be 6, and these would be 0. If it's 1, 2, 3, 4, 5, that means this would have to be 2. This would be 0. And this would have to be 4, and this would be 3. So I think we're guaranteed a 3 in one of these cells. Yeah. One of them has to be 0, the other one has to be 3. So that means 3 cannot be any of these cells. That means 3 must be in 1, 2, 3, 4, 5, 6, or 7. So this is 6 or 7 as a length. Can it be 6 this way? 1, 2, 3, 4, 5, 6. But then that would be the digits 3 through 8 guaranteed on the line. So it cannot go that way. I have one interesting thing. Would this be considered essentially the region borders dividing that line? Probably not, right? But I don't know. 1, 2, 3, 4, 5, 6. Okay. So this cannot be the same region as this. So obviously this has... Okay, so this can't be the red region either. But this could all technically be a yellow region here, right? Well, it would have to go here. That would be interesting. Can this ever be 4 is kind of the question, right? So I guess this would be a different region. That's possible. Oh, wait, no. So if this was 4, this would be 3, this would be 2. None of these could be the red region. So the red region, again, would have to go out this way. And would guarantee to have a 2 or 3. So this cannot be 4. Therefore, this must be 6. This has to be 0. This is 0, and this is 3. So this is a border. This is a border. So this has to be part of the red region here, then. So we have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 possible cells. It cannot go to here because it would definitely have... You would guarantee that you would have a 2 or 3 in this region, which is not possible. So this is all done. This is a region. And that's done as a region. Okay, so then this would have to be a 1. So 1 could not be here. This can't be 3, so this has to be 0 then. So this is either 0 or 2 here. So we have to have 5, 7, 8, 9 in the remaining red region. This can't be 5 because of 5 in the row. This cannot be part of this cell here because we need... Or this region. So this has to be a boundary. Again, it cannot be the full amount here. So this has to be part of... We have, okay, 6 at least. 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5, 6. So all of these 4 are part of the same region. That means these must be filled out. This is a separate region than 1. So one of these is probably pink. We don't know which. This has to be different than green, though. It cannot be the full amount here, because if it were just this, The problem is that would be the digits 3 through 8, which add up to 33 already. So this has to be part of it too. So this is a separate region because, again, you can't have 3. Oh, 3 doesn't have to be in that region. So this is actually not part of necessarily part. So this could be blue. Okay. We'll still mark it as pink, but it could be blue. It could actually stop here, and then 3 would be here, and this would be 7. So we have 1, 2, 3. No, this would be 6. 1, 2, 3, 4, 5, 6, 7. Wow. Can that actually work then? No. If this is 7, that means 3 is part of the region. Yeah, so this does have to be a different region. Okay, so I was right. If this is... So say the only way this is not the case. So blue is always part of this, going to contain this 3. If this is 6, this is 1, 2, 3, 1, 2, 3, 4, 5, 6, but 3 has to be in the 6th position, which is here. So it's going to be part of that region. If it's 7, then this is 1, 2, 3, 4, 5, 6, 7 in the region, and 3 would have to be in the 7th region too, or the 7th cell, but then it would be part of that region. So this is definitely not part of that region. This is probably then the pink, and then this is probably the yellow. So the yellow has to go somewhere. It's going to be blocked by the blue here. So it has to go somewhere. So it has to go out here. 1, 2. It could be 3, 4, 5, 6, 7, 8, 9. It could go here. It cannot... So one guaranteed... So does this have to be yellow is kind of the question. 1, 2, 3, 4, 5, 6, 7, 8, 9. The answer to that is no. It does not have to be. But this is at most 1, 2, 3, 4, 5. Okay, so this has to be yellow here. Because this is a board. This is 0 here. It could go this way. But then this would be too long. This would have 7 and 8. So I don't think... It can never go here. This could be a separate... That's interesting. So doesn't this force this to be 1 through 7? 2 is definitely here. 3 is definitely here. That means you have definitely 1, 2. You cannot be missing 1, 2, 5 or 1, 3, 4. You cannot be missing 2, 6. But to connect this as a region, it would have to be including 1 or 7, which means 1, 7 is also not removed. Therefore, this has to be a 0. So we can have 1, 2, 3, 4, 5, 6, 7. 8, 9. Or 1, 2, 3, 4, 5, 6, 7, 8, 9. Or 1, 2, 3, 4, 5, 6, 7, 8, and 9. Or 9. So we don't have any other guarantees here. Interesting. Hmm. Okay. These digits cannot be 1 through 3. So this is 4 through 9 here. Cannot have 8 or 9 here. This has to add up. So these are all valid. So these 4, 5, 6, 7. 4 can be in 4, 5, 6, or 7. So, okay. This can't be 2. 2 cannot be in 3, 4, or 5. 2 could be in 1, 6, or 7 here. 3 cannot be here because that would force this to be 1. So 1 has to be either in 2, 6, or 7 also. And these digits have to be filled. So it's either 3, 6 can be in any of the spots. So, but it can't, okay, cannot be, okay, this can't be 3 anymore. So this has to be a 3 here, which forces this to be 7. So then it concludes all of this. So this is blue, this is blue. So one of these two is blue, and then this one has to be blue. Because if it connects just this way, so say it included one of these, right? This is 1, 2, 3, 4, 5, 6, 7 cells already here. That means, so this is blocked this way. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 at least. So this is yellow. It could go here. We don't know. So 7 goes to the third spot. None of these could be 7. So 6 cannot be here. 6 cannot be 3, 5, or 6. Ah, this is not a digit. This has to be a digit, so one of these two at least cannot be a digit. Right, because that's 9 cells in 11 cells here. So 2 of these have to not be a digit, so one of these two cannot. Which means we have 1, 2, 3, 4, 5, 6, 7, 8, and then one of these as 9. So this has to be guaranteed to be this way. So this is yellow. That's done. So this is done as a region. That's done. And then we don't know where it actually ends. It could, so the blue as a region cannot go down here. Again, this is 1, 2, 3, 4, 5, 6, 7. So this is done as a border. It cannot go to here, because if it goes to here, then it has to connect to this part to be part of the same region. It has to connect to this part. So it has to be 1, this is 1, 2, 3, 4, 5, 6, 7, 8, 9 minimum, right? So it cannot go out. So this one is definitely part of blue. And these borders are done. This is done as a border. This is done. This is done. This is done as a border, and we don't know which one of these two we're going to. So this is 8 or 9, and this is 8 or 9 here. That means this cell as a region has to go that way. So we have orange. This is done as a border. Okay, so this has to be 2. So this cannot be 2 in this column then. We already have 2 missing here. We cannot go blue down here because that would be yellow. So one of these is missing again. So the blue has to go this way. So this is border there. This is the, sorry, this is not 8 or 9. This is 8 or 9 here. 6 cannot be, can be in 1, 2, cannot be 3, could be 4, cannot be 5 or 6. So 6 cannot be here. 5 is in one of these two cells. So 5 is either in 4 or 5, so this cannot be 5 here. This is missing 2 cells here. One of these 2 cells is missing. This orange continues out here. So this is at least 3. It has to be more than 3, so this is 4 at least. Um... This one has to go out this way. It's probably pink. But we don't really know. We have 2 this way, 2 this way. This one eliminates 1 here. This can't be 1 here. This can't be 1, so this must be 6. Wait, that doesn't work. Oh, this could be 1. There we go. This 6 eliminates... I don't know why I eliminated 1 there. Anyways. 6. This has to be 6 because it cannot be in any of these spots. It can't be in 7 anymore. That means 2 has to be in the 6 spot, so this is 2. This is either 4, 7, 8, or 9 here. That would mean this can't be 2 or 6, so this has to be 1, which means this cannot be 1. There has to be at least 3 segments in this cell. We're going to make this medium gray. I don't think it's orange. In fact, it almost certainly can't be orange. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, cannot be orange. This can't be 1 anymore. This can't be 6 because of the 6 in the region. Region. So this becomes a 4-5 pair. That's fine. 9 is either 4, 7, 8, or 9. Okay. This 7 eliminates 7 here. So that means the remaining digits in row 7 have to be a 6. So this has to be a 6. So this cannot be 8. That means 8 has to be in the 6th position. So this is 8. Remaining digits here are 5, 6, 7, 8, and 9. So we're guaranteed a 6 here. Remaining digits here. We have 1, no 2, no 3, 4, no 5, 6, 7, 8, 9. And these could be 0. This cannot be 1 or 7. No 7 here. No 5, actually, in this region. Okay. So it could go up here. It could go here. We don't know. So 9 has to be one of these 3. This can't be 1, 2, or 6 here. This can't be 1. So this is 3 or 4 here. 1, 2, 3. Okay, so 1, 2, 3, 4. So 3 could be 1, 2, 3. It could be 1, 2, 3 or 1, 2, 3. 8 and 6. We're not guaranteed anything here. So it's either 4 or it could be full 7 or full 9. We don't know. None of these can be 2 because of the 2 in the row. This can't be 2. No 1, no 1. No 1 here. This can't be 1 or 6. No 3s here. Okay. Uh-huh. We have 1, 2, 3, 4, 5. Okay, so these are all filled. Interesting. These cannot be 2, though. Interesting. 1, 3, 4, 5, 6, 7, 8, 9. This can't be 1 or 7. 3 has to be in 3, 4, or 5 here. That means this is one of these is 3, so this can't be 3 here. This can't be 3 here. 8 has to be somewhere here, right? 1, 2, 3, 4, 5, 6, 7, 8. And 8 can only be here, here, here. So 6, 5, or 4, or 1. So 8 has to be one of these. We're not sure which. Okay. This could be pink. This could be something else. These could be 0. Actually, don't we have to be missing exactly 2 cells in every row? I think that's the case, right? If we're not, say we're missing 3 cells in like this row. If that were the case, you would have to make it up in another row, right? So another row would only have 1 cell that's not part of a region. But then you would have a repeat there because you'd have 10 cells trying to fit 9 digits, which is not allowed. So you have to have 2 0 cells in every row. Interesting. Huh. This digit then has to be no 1, no 6. So 2, 3, it can't be 2 or 5. So 3, 4, no 5, 6, 7, 8, or 9 there. So you have to be missing 2. You have to have exactly 2 cells in each row which are not part of a region. Interesting. So that means this is guaranteed to have at least 1 cell. This is guaranteed to have at least 1 cell. Huh. Interesting. This is not guaranteed to have any cells. This is not guaranteed to have any cells. This is guaranteed to have at least 2 cells here. Okay, but it could be a completely different region. That's the thing. This is guaranteed. Well, we don't know. It's every row, right? So the restrictions are on the rows where we can only have 2 empty. We have to have exactly 2 empty cells. Interesting. Huh. That's an interesting restriction there. This can't be 1 because of the 1 in the row. This can't be 1 because of the 1 in the row. So if there's a digit here, one of these digits has to be where it is. So 1 cannot be here, 1 can't be here. So this digit can no longer be 2, cannot be 3. 1, 2, 3, 4. It can only be 4. So this was 0 or 4 here. This cannot be 1 because, again, 6 cannot be in the first spot anymore. It could be, so 2 cannot be in 1 because 1 can't be here. 2 can be in 2. 2 could be in 3. 2 cannot be in 4. 2 cannot be in 5. 2 could be in 6. Interesting. 3 can only be in, cannot be 0, or could be 0, cannot be 1, could be 2, cannot be 3 or 4, could be 5, cannot be 6. Interesting. If this were a real digit, it could only be in 3 or 4. So this can't be 2. 2 can only be in 2. Cannot be 3 or 4, can't be in 1. Because 1 cannot be in this spot either. Interesting. 3 cannot be here. 3 cannot. This can't be 2 or 3. Interesting. Because of that, 3 cannot be here, so this cannot be 4. 4 can only be in the first and the fourth positions. 2 could be in the first, but cannot be in the third. So this can't be 2. Interesting. So blue is done as a region. This is at least 3. We don't know this. It's either this way or it's this way, or it's both. Could be like this. Could be like that. Don't know. Can this actually be 6? No. If this is 6, 1, 2, 3, 4, 5, 6. Oh, I guess it could be. 6, 4, and 3 does work. So it could go that way. So that means 4 has to be in 2, 3, 4, 5, and 6. So this cannot be 4. This is guaranteed to be 3. Right? Because 4, this is the fourth cell, can only be in 2, 3, 4, 5, 6. And it's the size of its segment. So this can never be 4. This is 3, which means this can't be 3. This can't be 3 on this line. This can't be 3. So one of these two is 3. So this is 3 or 4 in length. That eliminates 3 here. So 3 can only be in the first spot. Here, if it's there. This can't be 5. So if this is not a 0, it's 2. We don't know what this is then. This can't be 3 because of the 3 in the column. One of these is 3. Okay, so this is not the same region as this. This cannot be, it could be 1 or 4 here. So this can't be, this is not 8. This can't be 8. So one of these two digits is 8. So this is either 1 in length or 4 in length. We don't know which. because this is already these 3 cells at least. So 4 has to be in 2, 4, 5, or 6. Okay. That's not eliminating enough things. If this is 4, this has to be 3. So 4 still could be any of these digits. So that's fine. What's interesting is if this is a full 9, this cannot be a separate region here. So this medium gray has to fill out essentially this part. Again, because these, you can only have at most 2 cells here, which are empty. This is at most 2 cells that are empty. This is at most 2 cells that are empty. So it could be just like 1, 2, 3, possibly. Actually, this would have to have 2 cells that are not empty. So, I mean, sorry, this would have to have 2 cells that are not empty because we already have 1 empty cell here. What are these digits? Cannot be 8 or 6. 1, 2, 3, 4, 5, 7, 9. So no 1. Okay, that doesn't tell us very much. Ah, interesting. Where is this 8, 9 in row 9? Row 9 and row 8. It cannot be here, so it must be in the yellow part of row 9. That means there's no 8 or 9. This 8 or 9 cannot be in the red part of row 8, cannot be in the yellow part of row 8. It must be in the orange part of row 8. And it cannot be 8 here because this is 6. So this has to be 9, which makes this 9, which means this is the full amount here as a region. So this is done as a region. Interesting. So this could be 1, but then that would force this to be 4. So either this is 4, in which case it's the full amount, or if this is 1, only one of these could be missing. So it has to go out here. This has to be missing. This can only be, I guess this could be part, no, it can't be part of another region. I guess it could. 3 and then going that way. Anyways, 9 is in the 9th spot. This cannot be 9. This cannot be 9. So these are the digits 1, 2, 3, 4, 5, 7, 5, and 7. Obviously, this can't be 2. This can't be 2 or 3. Seven can be in 2, 3, 4, 5, or 7. So it cannot be here. 3 obviously cannot be any of these. So 3 has to be in, cannot be in 1, could be in 4, 5, and 7. So any of those are valid. 2 can be in 1, 2, 4, 5, 7. 3 is definitely one of these 2 digits, so this cannot be 3 here. Interesting. So this can't be 1, because if this were 1, that would force 3 to be there, but we already know one of these two is a 3. Okay. We don't know what did. This is probably pink. We don't know, though. 2, 3, 4, 5, 6, 7, 8, 9. Could even be that way. Or 6, 7, 8, 9 that way. So gray has to go in here. So one of these is gray. It could... Okay, so at least 2 of these are gray. Can it actually ever go here? I think the answer to that is no, right? So if it avoided this cell, so at least 2 of 3 of these are gray. So if it avoided this one, it could do something like that. I guess that's possible. 1, 2, 3, 4, 5, 6, yeah. 7, 8. Okay, so at least 2 of these. So this medium gray cell region, we have 1, 2, 3, 4, 5, 6 guaranteed. It could be more than that, right? It could be all 9 of them are all the rest of the 9 are here. But we are guaranteed 6 here. Interestingly enough, though, this can only be one of these, both of these could be empty, or one of them has to be empty. That's the interesting part. Interesting. Okay. We have to go through some portion of this, though. It could go there. One can only be in 1, 2, 4, or 5. Yep. 2 can be in 1, 2, 4, 5, or 7. Cannot be in 5. 3 can be in... Cannot be in 4. It could be only in 5 and 7. Okay. So it could just go straight through here. That is possible. No, there's no guarantees here. Aside from number, there's no guarantees here. Oh, if this is 1, where does this go? It can't go along any of these segments, so it has to go here. But then this has to be 1 also. So it cannot be 1. This has to be 4 then, which forces this to be 3. So then... Yeah, this is all dark. That means this cannot be 4. So either 3 or 4 is in 1, or none of them are. So it cannot be both of these are in the same region. Right? The 3 cannot be here or here. 2 can't be here, so this can't be 2. 4 can't be here. 4 cannot be in the third spot, because then that would force this to be 3. 4 can't be... This can't be 2 or 3, so this is 0 or 1. This is 0 or 1. So either they're both missing, or 1 is here. So this, either way, if this goes to here... So this cannot be 3 anymore. The 4 signals that the 8 has to be in the 4th spot. So this is 8, which eliminates 8 here. These cannot no longer have 4 on the line. So 1 can be in 6, 7, or 9. The remaining digits are 1, 5, 6, 7, 9. This can't be 6 or 9. Because of... So that means 9 has to be in 1, 5, or 7. 7 cannot be here. 1 can only be in 6, 7, or 9, so we're guaranteed a 1 here. So 4 is here. It cannot have the same region as 1, so this is blocked here. This has to be 0. Or no, it could be another region. It could be another region. Right, so this cannot be 4. So 4 can only be in 2 or 5 now. This can't be 6. This can't be 4. Since this can't be 4, this 4 can only be in 1, 4, or 5. But there's a guaranteed 4 in one of these two spaces, which means this can't be 4 either. So if there's a 4, it's either in 1 or it's in 4. It cannot be in 5 and 6 anymore. Interesting. Okay. Interesting. So this could be a separate region here. We don't know. 3, 8, 5, 6, 9. So 5 has to be in 5, 6, or 9. Cannot be here then. Okay. 8 eliminates 8 in the rest of the column. This 9 means this can't be 9 here. This is 8, which makes this 9. 9 cannot be any of these. This can't be 9 because of 9 in the column. This can't be 9 because of 9 in the column. So 5 can only be in 5 or 6 here. Which means this can't be 5, which means one of these two is 5, so they both see this cell. So this can't be 5. So 1 can only be in 1, 2, or 4. Which means this cannot be 1, which means we have a 1 guaranteed here, which eliminates 1 from being here. So this is 0. So this is a border. This is a border, and this is a border, guaranteed. So this has to, if it goes here, it has to go up here. But that would mean this has to have a 1 on the border. So that does not work. So this has to be 0 too, right? Because otherwise this can only be 2. And it would only be there, right? So this is definitely a border. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there definitely, it has 2 cells in this region, at least on this line. Could have more. If it's O2, if it includes a 2, that means it has to include this. So to avoid, if it tries to avoid this, it can't go both this way, because then these are both 1s. This is done. Okay, so this is blocked there. Therefore, this dark has to go out here, which means this cannot be a cell. So this is 0. This cannot be 2 anymore. So this is either 0, 1 or 0, 3. One of these two has to be part of the dark region. It cannot be 0, 1. So this has to be 0 also, which forces this to be 3 in the dark region. This dark region must continue out here. We have 6 here, 7, 8 at least, and then we don't know where the last one is. So these are all filled out. Interesting. Okay. These are obviously bordered. It has to go that way. It has to go here. Ah, this is dark. So this has to be part of this. Well, it could be all that. But it can't be because it has to connect there. And it's only one cell. So this has to be a separate one. It's probably pink. But it has to include that one then. It's probably pink. Medium gray has to go in here. This is 3, so that eliminates 3 here. So 3 cannot be on this line anymore, so this is definitely 0. If it goes here, it cannot just include that. So I think this is always part of a region here. If it's not, so we try to have that, then this would be 1, signifying that 4 has to be in the first spot, which means that's part of the region. So this is always part of a region, which makes this 4. So this is 4, which makes this 5, which makes that 4. This can no longer be 4. This can't be 4. We have to have a 4 in one of these 2 cells there. These can't be 4 anymore, so 1 is in 1 or 2, so this can't be 1 here. 4 has to be in 4, 5, or 7, so this can't be 2 here. This 4 eliminates 4 as a possibility here, so this is 0. This can't be 4 or 9. These have to be filled out. So all of these are part of the region. 1, 2, 3. This has to be either green, pink, or some other, well, I guess it could be green, pink, or light. So these are guaranteed. 1 cannot appear on this line then. This is 0, so this is a border. So it has to go down here. 4 is here, so this must be 1. So this is part of it. It has to go here. And that's full region, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, so this cannot be part of the region and is 0. So that's done there. This can't be 4 anymore. So 4 cannot be in the 7th spot on this line. So 4 is one of these 2. This is 0. Okay, so that's... This is 0. We have 0, 0 here. Okay, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 9... Okay. Remaining digits in column 7. Cannot be 1. It could be 2. No, 1, 3, 7, 9. So 2, 4, 5, 6, 8. Cannot be 4 because of a 4 in the region. Okay. This 3 eliminates 3 here. So where is the 3 on this line? Cannot be any of these because of the 3 in the row. Can't be here. It has to be here. So this is 3, which means 7 has to be in the 3rd slot. So this can't be 7. This becomes a 4, 5 pair. This becomes a 1, 2 pair here. This is a 4, 5 pair. That's fine. 7's here. Remaining digits in the gray region are, we already have 1, 3, 4, 8. So 2, 5, 6, 7, 9. This cannot be 2 here. These can't be 6 or 9. These can't be 3. What the hell? What the heck did I just do? Okay. This digit has to be 2, 5, 7, or 8. Okay, so those are still, could be anything. Where's the 2 in this gray region? It has to be one of these two. So these two eliminates 2 here, so that's 1, which makes that 2. 1 can no longer be here, so this cell cannot be 6. 2 is here. 1 eliminates 1 here. 2 is one of these two. 9 has to be one of these two because it can't be here. Okay. Three is in the third position. That's fine. This is definitely part, so what digits can this be? No 1, 2, 3. It could be 4. No 5, 6, 7, 8, 9. Can't be 4. So this is what, 6? So 6 has to be in, so 3. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So this must be 7 here, which means this can't be 7. This has to be a cell. It's likely light. It could be dark. No, it can't be dark. This is 1, 2, 3, 4, 5, 6, 7, 8. Dark can only reach one of those two spots here. Pink could go to one of those. We don't know. This is definitely pink, but this could be like green technically. Cannot be light because this is separate here. So technically this could be green also. So this is either pink or green here. This cannot be green. Can it be light? 1, 2, 3, 4, 5, 6, 7, 8. It would have to be 9, 10 then. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or it could be 1, 2, 3, 4, 5, 6, 7, 8. And this could be a separate region? Technically, that could be the case. Interesting. 8 is one of these two digits here. That doesn't tell us anything necessarily. 5 is one of these two digits here. That also doesn't tell us very much necessarily. 5 cannot be here, because if this were 5, that would have to be 6. So this cannot be 5. So 6 can only be in the 2 or the 6 position. Why can't it be? Oh, this can't be 6 because then 3 would have to be there. And then we have that contradicted. Okay. This is definitely 7. This could still be 0. These could still be 0. Okay, so what are these digits? No 3 or 7. So 0, 1, 2, 4, 5, 6, 8, 9. Okay. This cannot be 2, 4, or 6. This can't be 2 or 1. This can't be 4. This can't be 1, 2, or 6. No 9 here. Oh, that's interesting. Okay. What does that mean? Where can 1 be? 1 can be in 1, cannot be in 2, cannot be in 4, cannot be in 5, cannot be in 6, could be in 8, but cannot be in 9, so that can't be 1. 2 can be in 4, no 5, no 6. It could be, cannot be in 8, or no, okay, this can't be 2 either. Can't be in 8 or 9. So this is 0, 4 here. Ah, wait, it can't be. This, we have 2 zeros already, so this has to be a 4. So this is 4, which makes this a 2. This can't be 0. This can't be 0. None of these could be 0. These are all filled out. So this digit is... okay. So this is 4. This is 7. Remaining digits in row 1 are 1, 2, 5, 6, 8, 9. Okay, 1, 2, 5, 6, 8, 9. 1, 2, 5, 6, 8, 9. This can't be 1, 2, or 5. This can't be 1. So 1 has to be one of these two digits here. Okay. Right, the reason why is we have 2 zeros here already in row 1, so that's the allotted 2 zeros we have to have in row 1, so this has to be filled. Yeah, these are the same. This cannot be 4 anymore. Okay, so 1 can be only in 1 or 8. It cannot be... one of these is a 1. So this is dark. I guess technically this could be green. Technically. Oh, this is only 2 in size. So yeah. This could... okay, this can't be pink. But this could be green here. Oh, interesting. So this is a separate region. Okay, so we'll make this light. So this has to be a separate region. And this goes either here or here. We don't know which. This is likely green. Okay, this 2 eliminates 2 here. One cannot be here because of the 1. 1 has to be one of these 2 cells here. So this can't be 1, which means this is a 1. So this can't be 1 here. Remaining digits. Okay, so let's look at remaining digits in row 3. Could be 0, 1, no 1, 2, 3, 4, 5, 6, 8, or 9. This cannot be 9 because of the 9 in the column. This can't be 4 because of 4 in the column. Okay, that doesn't tell us too much. This can no longer be 2, so this can no longer be 6. So 2 is either in 2 or 3, or it's neither. I think that means 2 has to be one of these two, right? If this is not empty, so one of these two has to be not empty. If this is not empty, that means 2 is here, which means this is 3. If this is not empty, that's 2. So either way, 2 has to be one of these two, which means this cannot be 2. Whereas the 2 in the gray region, medium gray region, has to be here, which eliminates 2 of the rest of the column. This could be still 0. These are all filled out. These are the same region. This likely has to be this region here. So yeah, this is green, this is gray, and this is pink. This could be technically pink or... wait, can this ever be green, is the question. So say, okay, 1, 2, 3, 4, 5, 6, 7. Yeah, this always has to be pink. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. The green has to, I guess, no, it could be 7 that way. 7, 8, 9. And then can green get all the way around there? Light can't. Because if light goes this way, then it blocks this from being a region. A full region. So what happens if we have pink going that way? So 1, 2, 3, 4, 5, 6, 7, 8. I guess 9. Then that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. No, cannot reach that. So this has to be pink. So this is definitely pink. This could be part of pink. Therefore, this has to be green here, right? This could be part of green. This cannot be part of green. These are separate regions. Can it be light? No, because it would block the green from connecting to each other. So this has to be pink here. So this is definitely pink. These cannot be green. This is lighter green, and this is green or potentially pink. Or potentially light, technically. Right? No, because that would block the green from connecting. So this cannot be light. So this is green or pink. This is dark. One of these two is pink. So we have 1, 2, okay. 1, 2, 3, 4, 5, 6, 7 at least. And we connect, that's 8. This could be a 0. We do have a 6, 7, 8, 9 quadruplet in column 4. And these are guaranteed to be digits. Because this whole line, this 3 guarantees this has to be a digit here. I guess this could be light also, actually. This could be light or green, technically. This can only be pink or dark. This is definitely pink. 4, 5. This could be 0. So we have 1 in the 1 spot. 2 has to be in the 4th spot. 3 is in the 7th spot. 4 is in the 2nd spot. 6 cannot be in the 5th spot, so this can't be 6. 5, 6 could be in the cannot be in the 8th spot or the 9th spot. So this has to be 6 here. So that's 6, which means this can't be 6. This is 8 or 9. So this is 0 or 4 here. We don't know which. This 7 eliminates 7 here. This 2 eliminates 2 here. Okay. So 1, 2, 3, 4, 5. This 6 eliminates 6 here. So where is the 6 along this line? It has to be here. Right? Can no longer be part of 7, so that has to be 5, which makes this 6. This 5 eliminates 5 here. And the rest of the dark region. So we have an 8. This eliminates 5 here too. We have an 8, 9, 8, 9 pair in row 1, which eliminates 8 and 9 in the rest of the row. This can't be 8 or 9, so this becomes 6, which makes this 2, which makes this 5. That eliminates 5 in the rest of the column. This 6 eliminates 6 here and here. We have a 7, 9 pair in column. What is this? 8? Column 8, which eliminates 7, 9 in the rest of the column. So this is a 0, which means this cannot be a 0 anymore. This can't be 9. This can't be 9. So this is yellow. We already had that border always there, but anyways, this is a border then too. We have a 7-9-7-9 pair here. 6 can no longer be in this region. So this is 5, 7, or 9 here. 9 is one of those two. 5 is one of those two. That's not helpful. We are missing... So this never has access to a 7. So 7 has to be one of these two cells, which means this can never be 7. This can never be 9 here, because this is a 1-7 pair. That forces this to be 9, which means this is a 1, and that's a 7. This 7 eliminates 7 in the rest of the column. So 7's either here or here. We're not sure which. Okay. This 6 eliminates 6 here, so this is a 0, which eliminates 0 in the rest of the rows. So this must be 3, 8, and 9. And this must be 3, 8, or 9. And these, so this is a boundary here and here and here. Guaranteed. This is, okay. This 6 eliminates 6 in the rest of the row. Okay. Remaining digits in row 4. You can always have 0. 0, 4, 5, 6, 7. So this can't be 7. This can't be 4 or 6. This can't be 5 or 4. Remaining digits in row 5. We have 0, obviously. 2, 3, 4, 5, 6, 7, 9. That's a lot. This can't be 2, 3, 6, or 9. Ugh. This spell can't be 2, 3, 6, or 9. This can't be 8 because of the 8, 9 pair in the column. This is 9, which eliminates 9 here, so that's 8, which makes this 9, which makes that 8. So 9's in the 9th spot, 8's in the 8th spot, so this cannot be 8 or 9. This still could be 0. This 8 eliminates 8 here, so this is 7, which makes this not 7, so it's 5, which makes this not 5, that's 8. So this can't be 5 here. So this is a 7-9 pair, which eliminates 7 and 9 in the rest of the row. So these cannot be 7 or 9. Okay. This is definitely a boundary. This can't be light. If it were light, it would block the green from ever connecting to here. So this cannot be light. It's green or pink. We have a 0-5 pair here. So one of these is 0, the other one definitely has to be 5. So this cannot be 0 or 5 anymore. This can't be 0 or 5. This can't be 0 or 5, so this is 4, which makes this 5. 4 eliminates 4 here, so it's 8, which makes that 9. This can no longer be 9 because of the 9 in the column. This is definitely a border then also. This cannot be 2 here. So one of these is... So... One of these 8s is a dark. This is pink or green. I don't think this can ever be pink. Well, maybe. 1, 2... No, it has to... How does it connect? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it can't connect. So this is green or light. Hmm. Okay, what are remaining cells? This cannot be 2 or 6. We have to have a 6 somewhere in this row. This can't be 6. This can't be 6 because it would have to be on the line. This cannot be 6 because it would have to be on the line. So this is the only 6 possible. So this is 6, which eliminates 6 here. If this were light, it possibly could be light. No, it would be blocking the green. So this has to be green. This cannot be pink. So pink could go this way. Okay, so pink to connect has to go this way. So this is a digit, so that's 4. That eliminates 4 in the rest of the row. 4 is one of those two. That's not helpful. So we have 1, 2, 3, 4, 5, 6, 7. We can either access this 8, or that 8. We can access 5 here, or 5 here, or 5 here. So pink could go up to here or here also, but that's it. So this is a border. We don't know if it goes this way, though. So those are the possibilities for pink. Let's not do that, actually. Let's clear those colors, because they could still be 0, and that's little... Okay, 5 eliminates 5 in the rest of the row. So this is a 0, 4 pair. One of them's 0, the other one's 4. So pink cannot go here, then, because we already have a 4. That eliminates 0 and 4 in the rest of the row, so this is 7. That's 6. This can no longer be 7. This green could connect out here, so this is still maybe not 0. I mean, maybe 0 still. Yeah, I guess we did do that one there, too. Oh, what's interesting here? So can this ever be light? If this is dark and dark, this must be pink, pink, pink here, which forces this to be green, green. So this can never be light here, I don't think. Either this is dark, or this is dark. This would be pink, pink, pink. And this could be pink, or it could be green, because this would be green, green here, if that's the case. If this is not dark, this is dark. So either way, this is dark, or this is green or pink. So where does the light have access to an 8? It can't be here, can't be here, can't be here. So it has to be here. So this is light. It either goes, it could go this way, it could go that way. Okay, light cannot go to here, because if it goes there, then this would have to be a 5. Well, I guess this could technically be green. No, green has to go through here, because this is a 6, right? If you connect the light here and here, green gets blocked from this area. So this is light, which means all of these are light. Therefore, this cannot be 8 or 9, it's 3, which eliminates 3 here. We have a 0, 2 pair here, which means we eliminate 0 and 2 in the rest of the row. This has to be 5. This has to be 3, so this is part of pink, which means this cannot be part of pink, which means this has to be 3, so this has to be all pink. This is not dark, which forces this to be dark here. This could still be green. But we know this is done as a region. Cannot go here because it has to be 3 cells here as a segment. This is done as a region. So if green cannot access here. Wait, that's problematic. Oh, no, 2 has access to this. Right. Green cannot access here, but it already has a 2. So this can never be green. And light can never access this because that, again, this can't be 2 anymore because the 3 is here. So if this were 2, that would force this to be 3, and that's not possible. So this has to be 0, this has to be 2, which means this is light. So we have a border here. This is a border here. It has to be green. There cannot be light. This is green or light. We don't know. So one of these is 4. It could access it that way. This cannot be 3 or 8, so this is 9. This is not pink. This is green. This must be green here because light cannot have that. Light has 1, 2. So to access this, it would have to gain a 4 or a 5. So that's not possible. So this has to be light to access that 7. So that's done. And the rest is green. So this has to be a valid number. So this is 5, which makes this 0. This cannot be light here. This is green. And it has to access it this way. So that's done there. So this is done as a region also. So this is 0 and this is 4. What does that restrict? This 8 eliminates 8 here. 7, 9 as a pair here. This 7 eliminates 7 here, so this is 9, which makes this 7, which makes this 9. So this cannot be 9. This becomes a 6, 8 pair, which eliminates 6 and 8 in the rest of the row, or the rest of the region. Also, this can't be 8, so this is 1. This can't be 8, that's 4, which means this is 7. That makes this 8, which makes this 5, which makes that 7. This 6 eliminates 6 here, so this is 8, which makes that 6. Uh-oh. Oh, do we have the zeros? Yeah, they didn't like the zeros. Okay. And that's a solution. Yeah, very hard puzzle, but not too bad. The logic behind it was actually very sound. Right? So it was very cool. It was a nice little, yeah, especially because of the, I've usually done I've done chaos deconstruction, but not with orthogonally connected regions before. So that was very interesting. And the limitations, particularly in the 9x11 space, was very interesting, right? It come to the conclusion that you had to have 2 empty cells in every row, because otherwise it just wouldn't work. So that was very cool. Logical deduction there. Yeah, just a nice little puzzle overall. Just very well set. I was used to that the segments had to equal each other, so that was at the very beginning, that was a little problematic, but it was pretty cool. Just overall, very nice, well-crafted puzzle. Definitely very hard. There's a lot of stuff you have to go through to be able to figure this out, but well worth it, I think. I hope you guys enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.